Hey everyone, welcome to my channel. My name is Arho Huttunen, and in this video I will show you how to write parameterized tests for JUnit 5. Parameterized tests make it possible to run the same test multiple times with different arguments. This way you can quickly verify various conditions without having to write a test for each case separately. If you're unfamiliar with JUnit 5, I would recommend checking out some other tutorials before proceeding to this one. And I'm trying to keep this video as short and as practical as possible, so let's get right into it. Let's start with an example where we have a string utils class whose job is to detect if a word is a palindrome or not. We want to write the test case for this, so we'll start with creating a new test class. I'm going to call this value source test. We want to check if a word is a palindrome, so I'm going to call this method isPalindrome. And I'm going to annotate this with the parameterized test annotation. Now, the simplest argument source is the value source argument source. So we are going to annotate the method with the value source annotation. It can take multiple types as arguments, but here I'm going to use strings. By the way, saippuakivikauppias is soapstone vendor in Finnish. Now our test is going to assert if the word given as an argument is a palindrome. And when we run the test, we can see from the output that the test method executed 3 times with different values of the string, and all the tests passed as expected. Let's take a look at another example. Let's say we want to check if a number is divisible by 3 or not. So we are going to need to use integers instead of strings. You can also specify things like different types of numbers, characters or booleans, and even classes. But let's just run the test to see that it works. Now the value source annotation doesn't accept null values. So what if we would have to check, for example, if a string is null or empty? So to deal with these cases, there is one special annotation called null source that will provide a null argument for the test. Another special kind of annotation is empty source, which provides an empty value if you have a string or some kind of collection as the parameter. So here we are going to check if the passed values are either null or empty. And when we run the test, we can see that it now passes. In this example, let's assume we have this kind of dateUtils class whose job is to get the month name from the month number. To be able to use multiple arguments, we are going to need to use the method source annotation. So I'm going to create a new test and call it method source test. So what we want to do here is to assert if a given number can be translated to a month name. So let's just assert that the second parameter matches what the dateUtils is giving us for the number. And we are going to annotate this method with the method source annotation and give a name of a method here as the parameter. Once we have done that, we also have to write a static method which is going to return a stream of arguments and has the same name we passed to the annotation. So this method needs to return a stream and we have to provide the arguments inside that. So I'm just going to use January, February and December in this example. Now if we run the test, we can see that the test was ran 3 times with the arguments we provided. If we want to, we can skip passing the method name to the annotation. So if we just use the test method name as the name of the static method as well, JUnit will automatically find it. This is not needed here anymore, and if we run the test, we can see that it still works. So what if we want to share these arguments between multiple tests? Well, the first option is to just move this static method into another class. So let's just create a new class called monthsProvider. and we'll just drop in the static method in this class. Now, when we go back to our test class, we are going to have to use the fully qualified name of the method. So that consists of the package name, the class name, and the method name. And we are also going to have to prefix the method name with the hash mark. So now running the test again, we can see that it picked the arguments from the external class. Another way to reuse some arguments is to implement an argument provider class. So I'm going to create a class called monthNamesProvider here. And I'm going to make this class implement the arguments provider interface. Let's just implement the method from the interface. And now we can basically just use the same arguments we had in the previous example. So there's another argument source annotation called, well, argument source. And we will just repeat the test from the previous example here. Now we'll annotate this with the argument source annotation and give our monthNamesProvider class as the argument. So now when we run the test, we can see that it works as expected. Another way to provide multiple arguments is to use the CSV source annotation, which stands for comma-separated values. So let's have here a couple of arguments called title, status, and the date. You should always assert something in your tests, but for demonstration purposes, I'm just going to output the argument values here. So when we add the CSV source as the argument source, it expects strings that have values which are separated with commas. So here I'll just type in the first argument and some kind of status, and finally a date. And let's do another one. So again, a string which holds all the three values separated with commas. And now when we run the test, we can see how the arguments were provided correctly. You can also provide these CSV values from a file. So here we have a CSV file inside the test resources folder. Each of the lines in the file hold the arguments separated with commas again. So if we go back to our CSV source test, we can now actually replace the CSV source annotation with the CSV file source annotation. And now we can pass the file name as the resources property. Yet again, running the test, and we can see that it works. There's a couple of more things you should know about the CSV source. So what if we wanted the value of the title to be null here? I'm going to get rid of this second line here just for the demo. And if we provide an empty value in the CSV string, it's going to be evaluated as null. So if we now run this test, we can see that's exactly what happens. So what about empty values? Well, you're actually going to have to use single quotes to get an empty string. And just to make sure it works, let's run the test again. And there we are. We have already been using some type conversions. So for example, here we have a date formatted in a certain way that gets converted to a local date. And we have an enum value that also gets automatically converted. So JUnit 5 has a lot of other automatic conversions. And I'm not going to go through all of them, but I'll link the documentation down below. So if your string format and the target types match, there's a lot of useful things here. There's stuff related to URLs, paths, a lot of date and time related stuff, even currencies, locals, and so on. If the automatic conversion doesn't work, there is also a fallback mechanism. So for example, here we have a person class that takes a string as the constructor parameter. Now we could write a simple test that takes a person as the argument. Let's just add a simple assertion here and then provide a string as the argument. So now when we run the test, we can see that the conversion worked. There's also another way for the fallback mechanism to work, and that is when the class has a static method that returns an instance of its own type and takes a single string parameter as the argument. So if we run the test again, we can see that JUnit now utilized that static method for the conversion. Sometimes we might have to write our own converters. So I'm going to write a conversion test here that tries to convert hex values to decimals. The converter is going to convert the string-based hex value into an integer, and we'll just check that the given arguments then match. So let's just use a couple of decimal and hex values here that are supposed to be equal. So now we are going to have to write our own converter. And I'm going to call it a hex converter. Now this class is going to have to extend the typed argument converter class, and it's going to convert a string representation of hex values to integers. And let's implement the missing method. And we are going to have to implement the constructor too. The constructor just requires string and integer classes here again. And the actual convert method is going to take the source string and parse the hex value from it. So now we are just going to annotate the argument with convert with and keep our converter there as a property. And we have to use the integer class instead of the primitive. So when we run the test, we can see that it passes. There is also one way to make this a little more readable. That is, we can actually write our own meta annotation. I'm going to call this just hex value. And this should be an annotation. That's what the at interface there means. I'm not going to go too deep into these annotation targets or the retention policy, but these should work for the test parameters. And finally, we are going to add the convert with annotation here with our custom converter. Going back to the test, if we replace the convert with annotation with our custom meta annotation, that will then apply our converter for the argument. So running the test again, we can see that it still works. By default, the arguments provided correspond to a single method parameter. But what if we would like to combine these into an object? So for example, here we have a task class that just happens to have a title, status, and a date created. How convenient! So what we would like to do is to just combine all these arguments into a task. But if we run the test, this of course doesn't work. So how are we going to achieve this? Well, we can start by creating a new class called Task Aggregator. This class then needs to implement the arguments aggregator interface. Let's just implement the method from the interface here, and now we can make this aggregator return whatever type of object we would like to. So we are going to return a new task. We can then use the arguments accessor to get the values we want. So for example, for string, there is this getString method that takes the index of the parameter as the argument. For types that are not primitives, we have to use the get method that also takes the type as the second parameter. So here we have the status enumeration, and then we also need the local date. Now, if we go back to the test, we can add an aggregate with annotation for the argument and add our aggregator as a property. So now running the test, we can see that the three arguments were aggregated into a single task argument. Let's go back to a previous test that was checking the conversion of numbers to month names. So if we run this test, we can see that by default it prints out the index of the execution and the argument values. But there's actually a way to customize this. We can add a name property here and type in how we would like the test name to look like. So index here refers to the number of execution, and then different numbers refer to the different arguments. 0 is the first argument, 1 is the second argument, and so on. So if we run the test again, we can now see, for example, that it reads as month number 1 is January, which I think is a little more descriptive. So there we have it. As you can see, there's quite a lot of possibilities with JUnit 5 parameterized tests. Please like the video if you found it useful and consider subscribing to the channel if you haven't already done so. Stay curious and see you in next video.